Hey, good day, folks. Welcome to Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at a type of graph where now we have a graph like that. Okay, yes, I want us to explore all the possible questions that you might be in a position of encountering. A police car is moving at a constant velocity with its siren on. Okay, passes a stationary listener. Okay, passes a stationary listener. The graph shows the changes in the frequency of the sound of the sound of the siren detected by the listener. So now, okay, can you see it started with a high frequency and then lower frequency? So it means now this object was here. Let's say the person was here. The car was approaching, okay? The van. The van was approaching, okay? Here's the man. The van was approaching the man initially, okay? So hence the detected frequency was higher. But now as time went by, the car passed the person. The car passed the person and moved and went away and moved away. Yo, dim. And moved away. So hence this one was towards, this one was away. So hence now the frequency it is like that. Okay, hence now the frequency it is like that. So this here, let me say this. This is the frequency of the listener when it was moving towards. Then this is the frequency of the listener when it was moving away. You do not know about the frequency of the listener. You do not know it. Uh, the graph shows the changes in the frequency of the sound source of the siren detected by the listener. Okay, calculate the speed of that takes the sound. Okay, cool. Now, state Doppler effect in weight. Doppler effect in weight says now the apparent change in frequency of the sound source detected by the listener because the sound source and the listener have different velocities relative to the medium of sound propagation. 5.2, write down the frequency of the sound detected. So write down the frequency of the sound detected by the listener as the police car approaches. When approaches, it is towards, it is 170 hertz. When it moves away, it is 130 hertz. A very, very interesting question and nice one. Now calculate the speed of the car. Take the speed of the sound in air to be 340 meters per second. Now, the minute you see 6 marks to 7 marks, just know it is simultaneous equation, right? So let's start first by saying, okay, when it is moving towards, what is happening? When it is moving towards, what is happening? You're going to say frequency of the listener is equal to V plus or minus VL divided by V plus or minus VS, frequency of the sound. Frequency of the listener when it is moving towards it is 170 hertz. Velocity is 340 plus it is moving towards the listener is at stationary. What's moving is the car. Then 340 minus VS multiplied by frequency of the sound. Can you see now we do not know we have two unknowns, frequency of the sound as well as velocity of the that one. Speed of the whatever the van. Okay, speed of the sound. Then now let's multiply this to the other side. It's gonna be what? 170. Okay, when I multiply this to the other side, it's gonna be, I will have something like 170 multiplied by 340. 170 multiplied by 340, something like 57,800 minus 170 VS, it is equal to 340 multiplied by FS, it is just 340 FS. Cool, like that. Then make this equation 1. Then let's see if it is moving away. When it is moving away, what happens? When it is moving away, we're going to say frequency of the listener is equal to V plus or minus VL divided by V plus or minus VS, frequency of the sound. Now, frequency of the listener when it is moving away, it is 130, then 340. When it is away, we say minus at the top, then 0, divide by 340. plus Vs multiplied by Fs, which is free state, I'm joking. Then 130 multiplied by, 130 multiplied by 340. 130 multiplied by 340 is something like 44,200. Remember, I just multiplied this to the other side again. Plus what? 130 Vs, it is equal to what? 340, 340 Fs. Now they are both equal to Fs, okay? They are both equal to Fs, 340 Fs, 340 Fs. It means I can equate these two. It means I can equate those two and say now this one is equal to, why? Because now equation 1 is equal to equation 2. Equation 1, it is equal to equation 2. They are both equal to 340 Fs. Then I'm going to also take this one and say, since value are equal, let's us play mathematics. I want to put this one on this side. Okay? Whichever side you put it, it's fine, okay? Just that I want it to be in the side for me. Then I take the 170 Vs to the other side. It's going to be 170 plus 130. I send something like 300 Vs minus 57,800 minus 44,700. I don't know if mathematics it is correct, but I see something like 13,600. Let me just confirm that. 57,800 minus 44,200. 18,600, very, very good. Mathematics, they're off by me. Vs, it is how much? Then I divide by 300 like that. Then I get something like 45.33. What? Meters per second. They want the what? The speed, okay? So very, very, very interesting questions they're off. How do they mark this? 1 mark for formula, 1 mark for this, 1 mark for that. Equating the two, then finding Vs2 for, I can see 5 marks in them. Okay. So however the other mark is gotten there. I don't know. How do you get that other mark? Hey, cool. Now we are done. Can you see Doppler effect is very, very easy. 10 minutes, 10 marks, 10 minutes, we are done. So thank you very much folks for joining me. Let's meet on the next video. Thank you. Hope you enjoyed.